Hello, world.
How's it going?
My name is David Silver. I am the curriculum lead for the Udacity SelfDriving Car Nanodegree program. Welcome.
And I'm Anthony Navarro. I am the product lead for the SelfDriving Car Nanodegree program. And we're excited to be here today talking to you about everything self-driving cars.
We are. Lots of questions coming up, and we hope there are lots more questions that you all ask. Anything you want to ask about self-driving cars, the Nanodegree program, we are excited to answer. First, we'll start with a little public safety announcement. So Anthony and I are both drinking. I've got Jack Daniels. Anthony's got
Corona. Sorry, not a better beer right now.
We should say that neither of these are sponsors of the Nanodegree program. We just went across the street and bought them. One of the great things about self-driving cars is that there are a lot of accidents in the world. An estimated, I believe, 1 million deaths a year.
There's a lot,
due to self-driving cars, 35,000 in the U.S.
You mean drinking and driving? Not due to self-driving cars.
Not self-driving, human-driven car accidents. Most of those accidents are caused by humans, and many of them are caused by alcohol. And so a future in which we can drink and not have accidents, I think, is a great future. And you should not drink and drive. Don't do it. Really bad.
Really bad.
But when you're not driving,
enjoy a few drinks.
Welcome to enjoy a drink.
And feel free. We've got the chat channel open. We're monitoring it, and so we'll be there to answer any of your questions. Hopefully, there's some good questions that come through. Otherwise, you get to listen to David and I talk about anything that we want to talk about, which may or may not be of interest to you. Right. So let's see. We've got a pretty good world audience, it sounds like, coming around here. So hopefully, we chose a great time. So first, is there any questions about the self-driving car curriculum? Hopefully, a lot of you are going to be signing up soon, have been accepted, or maybe you're just really interested in what self-driving cars are in general or how you get jobs in those.
Cool. So we have a bunch of people saying hi from Palo Alto. I saw a few people from Ontario, one person from Malaysia, maybe Venezuela, Michigan.
Mountain
and
View.
Somebody, let's see, somebody asked, what do you specialize in? So I worked on the autonomous vehicle team at Ford Motor Company before I came to Udacity. And at Ford, I worked on the computational hardware platform team. We actually called it the domain controller team at Ford. And so we were testing out a lot of the different computer platforms available to see if they were fast enough for our needs and benchmarking them. What did you do before you came to Udacity?
So I was actually over with Lockheed Martin, and I did some work on their satellite systems that they were doing, and then also on autonomous systems research and development. And so one of the programs I worked on was autonomous vehicles for the military and kind of doing a lot of different testing and things with that. So it was a lot of fun. Autonomous systems are kind of great. So looks like we've got some questions pouring in too. Is there any information available right now that describes the course content for each term? For example, topics covered syllabus. I actually think David's done a lot with that.
I have. For better or for worse, the syllabi for the 3 terms live on my blog. You can find them if you go to the Udacity homepage for the Nanodegree program. We actually link out to my blog, or if you just search for Udacity Self-Driving Car Syllabus in Google, they'll pop up. And we can actually even get one of our colleagues to post the links in the chat channel. There's a different syllabus for each term, term 1, 2, and 3. And we're actually finally going to pull those onto the actual Nanodegree homepage, so they're not just living on my blog.
Yeah. So there's another question about, do you have to attend the lectures live, or can you watch them later? So our lectures are actually all recorded, so you can do them at your own pace, at your own time. You don't have to do them around our schedule. And none of them are actually live. Every now and then we do some live walkthroughs or live events like this, but everything is always recorded, so you can always access offline.
Yeah, and actually, as far as the syllabus goes, in addition to simply directing people where to search online or where to go to online, I'll just run through the syllabus really quickly. So the program is 9 months long. It's divided into 3 terms of 3 months each. And each month covers a different topic in the autonomous vehicle technology stack, so that by the time you've done the entire 9-month program, you've gone through the entire self-driving car technology stack. So we start with an introductory month, that's month 1. Month 2, we cover deep learning, which is an exciting new field in artificial intelligence generally and very applicable to self-driving cars. Deep learning is all about using deep neural networks, which is a type of machine learning tool to learn from data. month 3 is computer vision. This is more of a traditional way or a classical way of using images to see the road. So things like look for yellow if you want to find a lane line. A lot of computer vision is now being superseded by deep learning, but it's helpful to kind of know both the standard approach and the new deep learning approach. So that's term 1, introduction, deep learning, computer vision. Term 2 is sensor fusion, localization, and control. So sensor fusion is how you use radar and LiDAR and fuse that data together using mathematical tools called Kalman filters in order to understand what the world around you looks like. So say you see a vehicle out here, or your radar tells you there's another vehicle out here, and your LiDAR, your laser tells you there's another vehicle out here. How do you figure out if that's one vehicle or 2 vehicles, and then track that vehicle or vehicles over time? So that's sensor fusion. Month 5 is localization, which is how we figure out where we are in the world. With GPS nowadays, that can seem really, really easy, but in fact, GPS is only accurate to within 1 to 2 meters. And if you think about like how big 1 to 2 meters is, if a car is off by 1 to 2 meters, it could be off on the sidewalk, and that would be really, really bad. So we have more sophisticated mathematical techniques like particle filters that help us localize the vehicle to within single-digit centimeter level accuracy on a map. So that's localization. Then month 6 is control. Control is how we actually turn the steering wheel and hit the throttle and the brake to follow a trajectory. And there are lots of different algorithms called controllers that can do that. It seems pretty simple. Like for you and me, it's like you execute a left turn. If you turn too hard, you kind of ease up. But for a computer, you actually need some pretty sophisticated algorithms to do that. And then the final term, month 7, 8, and 9, are path planning, an elective month, and finally system integration. Path planning is how we decide where to take the vehicle, both at the macro level, like how do we get between San Jose and San Francisco, say, and at the micro level, what happens if like a cat runs out in the road, what do we do? And so we build things like cost functions and try and predict the world out into the future, and then decide what maneuver we want to take and what trajectory we want to build, and that's the trajectory we ultimately hand off to the controller to execute using the steering wheel and throttle and brake. So that's path planning. Month 8 is an elective month where you can go deep on one of several different topics. We currently have electives in advanced deep learning, which is all about how you use deep neural networks to identify pixel by pixel what's going on in an image. You know, is this pixel the road? Is this pixel the sky? Is this pixel a car? Where is the free space in the image? So that's one option. The other elective is functional safety, which is how we verify that the code we're writing is safe and reliable. And then the final module of the program, the final month, is system integration, where we take all of this stuff you've learned and you work in teams to put it on the actual Udacity self-driving car, which we have here in Palo Alto on a test track. And that's one of the really, really exciting things about the course is at the end you actually get to put your own code on the actual Udacity self-driving car. It's something you don't have a lot of other opportunities to do, and so we think it's really exciting.
Yeah, awesome. I saw a few more questions come in. Do we have a job guarantee with this program? We do not, but we actually partner with a lot of hiring partners who are very interested in our students, and we have a careers team here to help you prepare for those interviews. So well, there's no guarantee. If you do the work on your end, we do the work to help you get to that next step and get you those interviews. And we do have other challenges like the Bosch Challenge we're just about to close, I think, that we're, you know, if you finish in the top 25 on that one, you are getting an interview with Bosch. So there are exciting things like that. Programming language that we use in the self-driving car course. We use Python initially, and then we get into C++. C++ is very important for self-driving vehicles, especially they're basically embedded systems, and you need a lot to happen really fast on the chip. So C++ enables that kind of communication. Tell us about vision-based cars, or I guess comparing vision-based versus using LiDARs. I would say it's not like using one or the other. It's, you know, they're better at different things. And so, you know, LiDAR is great for seeing, you know, 3D, the depth image, but it's not very good for like high density. And where you have camera, it's very good high density, but it's a 2D image. So you have to kind of combine those. And that's where David was talking about. The sensor fusion becomes very important in how you combine all these pieces together. What is the hardest part of autonomous driving algorithm design? Probably that nobody knows the answer yet. There's a lot. It's an unknown world, I would say.
Yeah. I mean, it's a fun field because so much of it is getting built out as we go. I mean, I think two really large pieces, and they do kind of encompass a large chunk of autonomous vehicles, are the perception stack, which is how do we perceive what's going around us in the world using cameras, radar, LiDAR, because there's just so much sensor data that can come in, and it has to all be processed on the vehicle because the latency up to the cloud and back is too slow. And so figuring out how you use the limited computational hardware you have on the vehicle in order to process all this sensor data fast enough to perceive the world around you is a really, really tough challenge. Another really hard part of autonomous vehicle technology is path planning. We have pretty much solved, or at least Google Maps has pretty much solved for us, how the part about how do we get from one city to another, but it remains really, really difficult to figure out, if you come upon a construction work site and somebody's waving you around or holding like temporary stop, yield signs that flip back and forth, what do you do? Or Chris Urmson, formerly of the Google Self-Driving Car Project, has a funny story about the Google self-driving cars encountering a woman in a wheelchair herding ducks in the middle of the street, and the car trying to figure out how to deal with that. There are just all sorts of crazy stories and videos that you see from self-driving cars. People driving down the wrong side of an interstate, and just path planning around all of those things is really, really challenging.
What is the job market for self-driving cars currently? Lots. I think every company that I know that's doing them is hiring.
And a lot of companies are doing it.
And a lot of companies are doing it. So if you're looking for a job and you have the skills, and we're here to teach you the skills, there are jobs out there. There's not a shortage of jobs at all. What are the specific? Oh,
I was going to say, I can even talk a little bit about the automotive industry and how that plays into the job market. So kind of the traditional automotive industry, you have what are sometimes called the OEMs, original equipment manufacturers, or just the auto manufacturers. So those are companies whose brands you probably recognize, like Ford or Mercedes-Benz, BMW and Mercedes-Benz and Fiat Chrysler are great partners of ours in the self-driving car program. They're looking to hire folks out of the program. Then there are what are called Tier 1 suppliers, and these are companies who you may or may not have heard of who supply really just the automakers. Their whole business is to supply components to automakers. So those are companies like Bosch, Delphi, Continental, all of whom are great partners of the self-driving car program. And they are hiring like crazy too because they're supplying self-driving car components and systems to the auto manufacturers. And then beyond that, you have what are called Tier 2 suppliers, and those are companies that may supply a lot of different industries, but one of the industries they supply are cars. And so Tier 2 suppliers will often supply components to Tier 1 suppliers who will ultimately supply a whole system to an automotive manufacturer. If you kind of follow that whole chain, a Tier 2 supplier might be a sensor manufacturer like Velodyne manufactures LiDARs, or it could be a chip manufacturer like NVIDIA, who is one of our partners in producing the entire Nanodegree, produces graphics chips that are incredibly important for self-driving cars because they allow parallelization of the computational hardware. So you have that kind of whole stack, and everyone in that stack is hiring. And then you have this kind of whole new stack of companies like Uber and Waymo, which is part of Google, and Didi, and Baidu in China, and even companies like Yandex in Russia, kind of internet companies that are beginning to look at self-driving cars. Apple has now finally come out and talked a little bit about their self-driving car effort. And so you have kind of the traditional automotive chain plus all of these tech companies, and they're all hiring like crazy to build up their self-driving car teams.
Yeah. So take our programming, get a job in self-driving cars. It's awesome. Do we have any specific requirements for the type of computer you will be using? Yes and no. With a good internet browser and a good connection, you can do everything in our videos. However, some of the projects, the biggest thing that they're going to need is, really when we get into the deep learning side, is the GPUs. Now we do give AWS credits out, but it's a lot easier if you have like your local machine that can do that. Ubuntu access is, I like using Ubuntu. You can use VMs and things like that, but at least a decent computer definitely helps get you through these projects. Can you explain some of the projects you make during the Nanodegrees? If you want to run through a couple of them, but I think you did a pretty good job at the syllabus too.
Yeah, maybe you're tired of me talking. I'll just pick out a few. So one of the most popular projects is within the deep learning module that's fairly early on in the program, and it's called behavioral cloning. And the idea with this project is that you build a deep neural network and train a deep neural network to clone human driving behavior. And the human in question is actually you. This is done in a simulator. It's a little bit like a video game. And you'll download the Udacity simulator onto your own computer, and there's a car on a track, and you drive the simulated car around the simulated track, just like in a video game, and all of that data gets recorded to your computer, and then you use that data to train a deep neural network, and once you've trained the network, you can actually switch the simulator into autonomous mode, and your network will drive the car, and so you get to see your deep neural network driving the car around the track. And now, of course, it's not that simple. It takes a lot of tries to finally get your network to a place where the car will drive around the track, and it can be even sometimes a little bit of a frustrating project, but the reward when you finally get the network to drive your car around the track autonomously is really, really fun.
I will say that as a student, that was like one of my favorite projects, and it, like David said, it was kind of frustrating for a while, and then when it worked, it was like jumping up and down, you know, trying to keep quiet because it was like middle of the night, but super happy that it actually worked, so it was a huge sense of accomplishment getting that done.
Another project much further along in the course at the beginning of term 3 is our path planning project. That's again in the simulator. And in this case, it's a simulated highway, 3-lane highway or 6-lane highway, 3 lanes on your side of the road. And you have to build a path planner that plans several seconds out and figures out, you know, when you should change lanes to pass vehicles to get where you're going faster, but with all sorts of constraints, like you can't exceed a speed limit, you also can't exceed acceleration and jerk limits. Jerk is kind of the next derivative after acceleration to make sure that the ride is comfortable. And that gives you a real appreciation for how difficult it is to build a path planner on the road, and it's a great portfolio project to take to employers. And then the final project of the Nanodegree, actually getting to put your code on the car. You learn about ROS, Robot Operating System, which is the automotive middleware framework that our car runs on and that runs on a lot of cars, particularly in academia. It's a great skill set to have to be able to go to employers and say you've worked with ROS and built ROS nodes to drive a car, and you get to work with a team to pull together sensor fusion and the sensor processing pipelines you've built, and neural networks, and the path planning you've done, and localization filters that you've built, and actually get them to run on a real car. So those are a few of the different projects in the Nanodegree.
Yeah, great. Another question that I've seen come up a lot is how many hours does it take for somebody to do this course? Now, we like to say 10 to 15, but really it kind of depends on your background. If you understand a lot of this stuff really well, if you've been through computer vision classes, if you have a background in this, it's going to take less time. But if you don't have that background, it's going to take a little bit more time. So it's a good estimate, just kind of do the first project and see how long it takes you for that, and then start doing the second project, because it is a little bit harder for the second project. And start gauging that early, but estimate between 10 and 20 hours, I would say, to really get a good understanding of that.
Yeah, we survey students, and I think the average number, and it is an average, there's a big range, just like you were saying. The average number of hours students report spending on the program per week is about 17, which is a really big commitment. You know, many of our students have full-time jobs. It's a lot to do, but on the other hand, students generally tend to be really, really excited when they complete the program. They've learned a lot. They feel like they've developed a whole suite of skills that they didn't have just a few months ago. So it is one of those things where what you put in is what you get out. Yep.
Does this course involve a team project? It does. As David mentioned, the final project where you get to put your code on the car is a team project. So, you know, you work with team members, and, you know, I think that's very important because in industry, you're always going to be working on a team. So it's good to get that experience. You see, you know, you get to collaborate on this big project, and then altogether, you get to put your code on the car. And so it's really exciting. Will the content be good enough for people from other backgrounds to get a job? Absolutely. That's the whole point, is you don't have to know this stuff already coming into it. You know, like David said, you get in what you put in, or you get out of it what you put in. So if your background's in web development or something else, and you come into this course and you really work hard at it, and you develop great projects, and you develop this portfolio basically to go show an employer, absolutely. We have our students already getting hired, and the program's not even completed. So it's definitely capable for that to happen. Term 3 syllabus, David talked about that a little bit. There should be a lot of information on Term 3 that's out there. So if you're not able to find it, we can look into that a little bit. What is the difficulty level for this program? It's not a beginner program.
I mean, we designed the program to help people who are already software engineers prepare for jobs in the autonomous vehicle industry. So that's kind of how we approached it. We do have people in the program who are not software engineers, have some background in software engineering. Maybe they studied math or even like computational biology. We have an accountant I know who's doing quite well in the program, who's taken other Udacity courses kind of as a lead up. So you don't have to be like a rocket scientist. You don't have to be Superman to complete the course, but the course is designed for people who know how to code, and there are prerequisites, and in general, if we admit someone to the program, we expect them to be able to succeed based on what we've seen of their background, if they're willing to put in the time. A lot of it really is just about putting in the time and the effort. It's really easy on a Saturday afternoon or a Tuesday night to say, I'd rather watch TV than like code up my behavioral cloning project or learn about Kalman filters. And so a lot comes down to like, how excited are you about this and how much effort do you want to put into it?
Yep. What's the hardware in the car?
The hardware in the car, there's a lot of hardware in Carla, our self-driving car. We have Velodyne LiDARs, VLP16s, and HDL32 LiDARs, so 16 and 32 beam LiDARs. We generally don't run them both at the same time. We usually run one or another. The 32 we use more for actually building a map, and then the 16 can localize to that map. We use Delphi ESR radar. We have point gray cameras. We have a data speed controller that talks to the CAN bus inside the car. CAN is control area network. That's the actual network running in the car. We did not have to hack that ourselves. We purchased the vehicle from Autonomous Stuff. Autonomous Stuff is an Illinois-based company that makes cars that are drive-by-wire. So they're not self-driving, but Autonomous Stuff sold us this vehicle and handed us a PlayStation controller, video game controller, and said, look, you can drive this real car with a video game controller. And in fact, we could. We could just like stand outside the car and drive it around like a remote control car with a video game controller. And they said, if you can drive it with a video game controller, you can program a computer to drive it. And so that's what we did. That was our job, is to program the computer to drive it. The computer we run has an Intel i7. I forget how many gigs of RAM it has, and an NVIDIA Titan X GPU. And we're looking at other computational platforms like the NVIDIA Drive PX2 that might run in the vehicle as well.
Great. Is there a grading pattern to this program? I'm assuming that means that you're asking how the projects are getting graded. So the projects are graded with a rubric, and it's pass-fail. So as long as you hit everything in the rubric, complete the project, you'll pass the project. Are we going to do practicals? I don't know what you mean by that question, so if you can clarify, I'd be happy to answer it. Do we have any success stories of the program? We do. We have a lot of success stories, actually, and I think I have a lot even just that we know personally and there's many more that we don't always hear about. But I have people that are working at many of our partners, and then many people that even aren't partners are hiring our graduate, or not even graduates yet, hiring our students because they're showing this capability in this.
Yeah, I was actually, funnily enough, a few weeks ago at the office of I guess I'll leave them unnamed, a major automotive manufacturer here in Silicon Valley. And I was sitting out in a common area talking with someone about collaboration between them and Udacity. And someone walked by and just kind of looked over at me and said, "Do you work at Udacity?" And I said, "Yes." And he said, I took the self-driving car course. Were you in the self-driving car course? I said, yes, I was in the self-driving car course. And he said that he had done the first term of the self-driving car course and then gotten hired onto the autonomous vehicle team at this automotive manufacturer. And so there are just lots of stories like that we're starting to see with students getting jobs at automotive suppliers, manufacturers, tech companies, other types of companies working on this stuff, defense contractors, all over the place.
Great. How many dents are on the self-driving car?
There are no dents. There are a couple of holes in the bumper. When we bought the vehicle from Autonomous Stuff, they had two VLP-16 LiDARs, two little pucks basically, kind of on each side of the front bumper. And we discovered as we were working with the vehicle that that having the pucks in the front bumper wasn't ideal because you didn't get a 360-degree wraparound view of the world. You just kind of saw like maybe 180 degrees in front of you. And so we removed the pucks from the front bumper and put them up on top of the vehicle. So now there's some holes in the front bumper.
I'm going to try to push through a lot of these. We're stacking up on questions now.
Oh my goodness, all right,
let's push through a lot.
We'll be quick.
Is there a Slack or other collaboration forum? Yes. Which one's the public?
So there's a public Slack community at nd013.slack.com that you can join right now. There is a student Slack community that you have to enroll to join at carnd.slack.com. And then we also have forums at discussions.udacity.com where you can, they're more like Stack Overflow, like for asking questions.
Is there any specific requirements for setup in my car? Udacity uses the Lincoln. We do because we purchased it from Autonomous Stuff, and you can definitely go purchase something from Autonomous Stuff. It gets a little bit more fuzzy if you're going to try to turn your own car into that, into an autonomous vehicle, and there's a whole lot that goes into doing that. And we don't cover all that kind of stuff in the course because there's a lot of electrical, safety, many, many issues around that.
Yeah, the purpose of the course really is to prepare students for getting jobs in the autonomous vehicle industry and not so much to actually build your own self-driving car. That is a major and very expensive effort. What we're focused on is helping students get jobs.
How proficient should I be in Python, right, in Python at the start of the program? I would say you should be able to solve problems with Python, not just like understand the syntax of Python, but actually solve problems with it. If given an abstract problem, go into Python and solve that problem. If you can do that, then you're probably at a good spot. Requirements for assignments, computer with a GPU. So I used my laptop that had a GPU in it. It was kind of slow, but it wasn't awful. If you can get a 1080 or something higher, that's great. But a laptop and a gaming GPU, or at least I had a little bit of a gaming laptop, that would be fine.
Yeah, I mean, you don't even have to have a GPU. As Anthony mentioned, it is helpful, but we provide credits for launching Amazon Web Services virtual servers that have attached GPUs. So if you don't have your own GPU, you can use that.
This person's asking about, they're a little concerned about the pace week to week due to family and work commitments. Are there weekly deadlines, homework projects, and is there some flexibility? So every project has a deadline. However, those are flexible deadlines. So if you don't hit it by the deadline, that's okay. You can still submit it later. What is the kind of like the hard deadline is the end of the term. So you still, where you might have weeks that you can do more and weeks that you can do less. But by the end of the term, all of the work has to be done and turned in and graded in order for you to pass the term and move on to the next term. Somebody likes Jack Daniels, and hello from Virginia.
I'm from Virginia, from Reston, Virginia. Reston and Vienna, both towns.
Is the market for self-driving car engineers already full? Absolutely not. As we were talking earlier, there's companies looking left and right, and every day there's more. I think Samsung announced something today, and now they're going to be hiring a bunch of engineers, and they are one of our hiring partners. So, any comment that big tech companies such as Google or Apple showing a little step back of self-driving car?
Apple, I mean, there have been some stories in the news recently about kind of the journey of Apple, and they've had a kind of an interesting journey because they've been so secretive. Google seems to be just kind of forging ahead. They're launching their Chrysler Pacifica minivans, self-driving minivans. There are a ton of them now in Mountain View, just driving all over the place, and supposedly they're picking up real passengers in Arizona. So it seems like they are forging ahead full speed.
Yeah. How do you deal with direct sunlight on the camera? That's where we get into sensor fusion, and you learn how to rely on other sensors besides the one that may not be very reliable at the time. How to learn C++ from scratch in this course. So we do have a module that kind of goes over C++ basics. So it's a C++ for programmers kind of idea. So you already know how to program in Python. You've already finished a term in Python at this point, and then you can get into C++ and do a little bit from there.
There also is a free Udacity C++ course in the Udacity course catalog that basically we built for the self-driving car Nanodegree, but you can just go now and search for C++ in the Udacity catalog and join that course if you want to get a head start.
Are most of the hiring partners and opportunities US-based, or do you have partners in other locales? We do have other partners in other locales. However, just because of, I guess, the nature of it and the companies that are doing this kind of research, it's a lot happening in the US. But there are companies other places that
Yeah, we have a number of companies in Germany. So of course Mercedes-Benz, BMW, Volkswagen, Audi, also suppliers like Electrobit, Continental based out of Germany. We have companies in India, a number of automotive supply type companies like HCL in India. And a lot of these big multinationals like BMW, Mercedes-Benz have offices all over the world. China, we just had an event here today actually with Didi, the Chinese ride-sharing company. Japan has a lot of self-driving car companies that we don't have formal partnerships with all of them, but we work close to many of them. So there's a lot of work going on all over the place. Canada has a number of offices now. Uber and GM both have big self-driving car offices in Canada.
Great. Can we reuse the code we write in this course? Any IP restrictions? Absolutely. We own everything. I'm kidding. We definitely want you to put it out there. It's all open source. You know, whatever you do with the code you write is for your business. You know, we're here to promote the education in this area. We don't take any IP in anything you do with our courses.
I think there's something in our terms of service that like maybe we can use your code to like demonstrate, like show people like samples of what students have written. We have to go back and double check our terms of service, but you do retain right to your IP.
How are we going to do practicals with LiDARs or other physical practicals? Okay, so this is kind of the final project I think you're referring to. So when we have actually hardware in the loop, we can talk a little bit about this, but basically you're going to send us your code. You're going to work with your team. You'll send us the code. Then we will deploy your code on the car and run it and see if it passes, you know, the project.
Yeah, so that's kind of how the final project works. We have a simulator that ties into ROS that simulates LiDAR and radar data really, really well. So, so the goal is that when you run your code in the simulator and it works, it should work well on our actual vehicle. We also take sensor data, right now primarily camera data, but we're looking at ways to take radar and LiDAR data and use them for different projects. So there are projects in the computer vision module of the course where you do lane finding and vehicle detection using camera images or videos taken from autonomous vehicle cameras, our autonomous vehicle cameras. So it's possible for us to send you sensor data basically, and that's how you work with them.
What are the most commonly used parts of math in the course? Statistics, calculus?
Statistics is probably the most commonly used. Bayesian statistics just kind of shows up everywhere in autonomous vehicles, in things like Kalman filters and other types of filtering mechanisms and algorithms. Linear algebra may even be more commonly used than statistics because you're doing a lot of kind of systems of equations type solving. There's also a little bit of calculus, but it's not as prevalent. Basically, if you're familiar with derivatives and integrals of polynomials back from high school or college calculus, then you should be in pretty good shape. Yeah,
you want to be familiar with the notation and how to implement it in code, but not actually, we're not going to make you solve an integral or anything like that.
Right. You should be familiar with like how to multiply matrices, which is not difficult. If you've never done it and you take a quick refresher, we link to a few on our course homepage. You can pick that up pretty quickly.
A lot of these companies are requiring candidates to have 3 to 5 years experience, so they're actually interested in fresh college graduates. Well, yes, but I would say if you're kind of brand new to the area, you have a little bit more luck at a big company. When you're looking at these startups with maybe like 5, 10, 20 employees, they're moving really fast, and they really need somebody who can come in and just hit the ground running and kind of provide stuff. And so you have a lot better chance, I would say, getting a job at one of these bigger companies where they have, you know, hundreds or thousands of people, and they can kind of foster teaching you and guiding you and helping you grow your skills. What are the obstacles to get to level 5?
Well, we should maybe first define what level 5 is. You want to take a crack at that?
Sure. So you've kind of got level 1, 2, and 3, which are kind of like semi-autonomous. And these are SAE standards, by the way. But they're levels of, you know, fully autonomy. So you've got like level 1 is no like autonomy. Level 2 is some driver's assistance. Level 3 is more driver's assistance. Level 4 is self-driving in most conditions. And level 5 is completely on its own, self-driving, no human intervention. This is where you could take the steering wheel out of the car and everything's fine. There's technological restrictions to that, and then there's also like policy restrictions to that. And so technological side is, I mean, there's just, the world's unknown. The roadways are unknown. People do sporadic things. So there's just a lot of unknown things that computers have to be able to understand, and we're not quite there yet. And then the policy side is just, can we get a company to release a car without a steering wheel in it and call it good? And so there's a lot of challenges around that. If it takes me 3.5 years to finish, will there still be jobs? You're getting your master's in CS. This area, I mean, it's always hard to predict the future, but this area doesn't seem to be going anywhere anytime soon. There's a huge amount of investment from many, many companies in this sector, and all you're going to see, I think, is growth and more jobs and more entry-level jobs too. Or, as you finish up your master's, definitely, ready to jump into that kind of stuff.
Yeah, I mean, we should highlight, hopefully it does not take you 3.5 years to finish the Nanodegree program.
Yeah.
In fact, I don't know that we would let you take 3.5 years to finish the Nanodegree program. In general, you have to finish each term in about 3.5 months, complete the various projects, the usually 4 or 5 projects required for the term. You can take time off between terms as long as you want, so that, I guess, would be the way you stretched it out for 3.5 years, but we certainly don't want for you to have to take that long to finish.
Will the first term have any machine learning centric projects?
The first term is pretty heavily dependent on machine learning and deep learning specifically. So you build deep neural networks to classify traffic signs. And the behavioral cloning project I mentioned, where essentially you're driving and recording data, steering wheel and throttle commands from your driving around the simulator, and then you train a deep neural network to mimic your own driving behavior. And then we use more standard computer vision techniques to do things like lane finding and vehicle tracking. And even there you can use machine learning, things like support vector machines, to classify whether different bounding boxes have captured a vehicle or not. And you can use machine learning to tune your hyperparameters for lane detection. So there's a lot of machine learning in term 1.
Why don't we have a point cloud processing project?
That's a good question, and the answer basically is that the most important thing that employers want, based on our conversations with employers, is facility with Kalman filters, or at least that they want for sensor fusion engineers. So point clouds are what you get from using a LiDAR to collect data about the world. Basically just all these little laser pingbacks in a point cloud. If you've never seen one, you should type it into Google image search, like LiDAR point cloud. It's pretty neat. And so what we did for the sensor fusion module is we took those LiDAR point clouds and found where the vehicles were in them and just returned back a single point for the vehicle, and then have you build Kalman filters to track those points and vehicles over time. Now, of course, the part we did of taking the point cloud and figuring out where in the point cloud the vehicles actually are and where the centroid of that bounding box is itself a very hard problem. It's possible we might build an advanced sensor fusion elective module that would incorporate working with point clouds, and I would say it even seems likely, but nothing's for sure. And that would be a really, really neat project. But the first thing you really have to master is using Kalman filters to track those vehicle locations over time, because Kalman filters come into play in a lot of different places for self-driving cars.
Is it difficult for a bachelor's in computer engineering to get a job in self-driving cars? I think that's actually the perfect, kind of background.
Yeah, I mean, an interesting thing is happening with self-driving cars that I even saw myself at Ford, which is that self-driving cars used to exist in the research departments of these big companies or in research groups at universities. And so it did tend to be something that you needed a PhD or at least a master's to work on. And self-driving cars are now just really getting picked up fast by industry, and they're moving from the research divisions into production divisions. So companies are actually starting to build these vehicles, and one of the things that you see at big automotive companies is when something moves onto a production track, it becomes like a freight train. There's just nothing that can stop it. And when there are issues, they just kind of throw more engineers at it. And so the types of engineers that you're seeing working on these projects have gone from being kind of PhD academic style researchers to really industry software engineers, people who can write code and get things done. And so having a PhD is still a huge asset, particularly if you're looking at working on the research end of this, but there's a lot of production work going on now to actually get these cars to work on the road.
Right. For the final project, are people going to be able to come to the office and see their code run themselves?
Yeah, I think so. So we're just getting the first cohort of students into the final project now, and we just a few weeks ago kind of got everything finalized with our test track here in Palo Alto and got that set up. And so we're working out how we're going to have students come to the lot to watch their code run. You do not have to come to Palo Alto to watch your code run, but if you're interested, you happen to be in the area, or you want to come to the area, it's an opportunity we would like to provide to you, and so we're working out the logistics of that.
Yep. So this is a great comment. I'm currently in the self-driving car program, and David, I just want to say you do a great job in the lessons, but a few of your engineers look like they're being held hostage by Udacity. Little do you know, David has like a little room of engineers that he keeps that he can pull out when he needs.
Oh man, oh man.
Well, we'll work on some of that feedback. But yes, David does do a great job in the class. How are mentoring and careers, how do mentoring and careers help? So our careers team is here to like review your LinkedIn, your resume, GitHub, I think. All your kind of professional tools that when you go to an employer that they might want to see, our careers team is here to help you with any of that. Mentoring, we have switched from like one-on-one kind of, or I guess one-to-many individual model or mentoring model to a live help. So now there's a box that pops up and you can type in and you can ask your question. And I think that's in the later course. I think the
earlier in term 3 right now.
Okay, so we're looking at that. We're kind of seeing if that's going to help more. But we have these two models. One where you have a mentor that you can ask a question to, and they get back to you in about 24 hours or so. And then the live help where you have a box that pops up, you can type your question, and then a mentor, not maybe your mentor, but a mentor comes back and gets to you within usually a few minutes. So.
Yeah, I mean, one of the interesting things about self-driving cars, when we built it, or we started building it, we knew it was going to be a pretty challenging program, and that it would be a really important program for Udacity, just in terms of visibility for the company. And so we started running a lot of experiments and putting a lot of resources into seeing how can we help students be most successful. And one of the experiments was mentorship, giving each student a mentor. And we really see like kind of binary feedback on that. There are some students who say they just aren't really interested in having a mentor, it's not particularly helpful. And there are other students who say that the mentor really like makes the difference between them being able to succeed in the program or not. And so one of the things we're trying to do is really focus in on what makes those mentor-student relationships successful, and then try and provide other tools for folks who maybe just aren't interested in that.
Do you deploy every student's code on Udacity Car? Every student that will join a team. So at the end, you join a team, and your team will deploy it. So it's not every individual, it's just every team. So every student can contribute to that code going onto the car. Sounds like, deploying on the car is at the end of the program. Yes. And the terms are, so there are 3 terms, and each term is $800. Is there age discrimination in this field? You're 43 and you're a web developer. I hope there's not. That's illegal. So hopefully there's not. And we want everybody to join from high school. When we have had everybody join from high school age to, I don't know what our highest or oldest person is that has joined, but if you can do this, I think these people care about the jobs more. Like they want, or the skills. They want you to be able to do the job. If you can do the job,
yeah, I mean, there really is one of those situations where there's such a huge demand for people who can do the work that there's not really a lot of room to be discriminatory.
Yeah. How does the team project work with everybody working remotely? Say nobody's in your area. Great question. It seems kind of hard, right? But I actually was part of this Udacity self-driving car race team that we did back in like April. And I was a student at that time, and we had 17 people from 5 different countries. And that's a really big challenge when we basically got dumped in a Slack channel and had to figure it out. And within 6 weeks, we deployed code onto an actual car and really only had the car for 4 days, 2 days before the event. And we were able to successfully deploy code on there. So, I mean, with the internet these days, there's so many tools that you allow collaboration and working together and just, communication that you'll be able to make it happen. And we're also enabling the tools on our side to make that easier for you. So as you get to term 3, we're running our first students through that right now. We're gathering feedback, seeing what we did right, what we did wrong, and then how we can make the process better for every student as we go forward. What type of math is used? I think we went over that a little bit. Is there necessity into enrolling your machine learning course and then autonomous driving? There's not. We're going to teach you the machine learning pieces that you need to know. And so if you want to take the machine learning one, absolutely take it. But if you just want to take it to get to autonomous vehicles, then come take our self-driving car course. Coming from the Deep Learning Foundations program, that is the deep learning part of self-driving car. Does it do everything from scratch again, and what are the new parts of the deep learning from self-driving cars? So we touch on some of this stuff, but we don't redo everything that's in there, and we do a lot more outside of deep learning. And we do more advanced pieces of deep learning that the Deep Learning Foundations course doesn't get into.
Yeah, so one of our team members actually was kind of helped us build out the deep learning component of the self-driving car Nanodegree program, and then bounced over to Udacity's deep learning Nanodegree Foundations program. And so he has kind of some good insight into both programs. And the way he likes to put it is that the Deep Learning Nanodegree Foundations program is broader. It covers more things. There are things that that program covers, like natural language processing using deep neural networks and generative adversarial networks that are fairly advanced topics that we don't cover in self-driving car because they're a little bit less relevant to getting a self-driving car to run. And we tend to focus a little more just on the things that are directly relevant to self-driving cars, like convolutional neural networks, transfer learning, behavioral cloning, semantic segmentation. And often the projects that we have are more difficult and like a little more kind of narrowly focused on what you need for self-driving cars. So it's kind of we're deeper, and maybe the Deep Learning Nanodegree Foundations program is broader.
What do you mean by a team project for the final one? Do you mean only one code will run on the car? Yes. So you'll work in a team of about 4 or 5 people, and you work together to get one, concise piece of code, and we'll put that on the car, and we'll run that code. What if I can figure out how to code and can work my way through the course, but I'm not a software engineer? What are my chances of getting a job? I mean, if you get accepted to the course and you get through the course, your chances are just like anybody else. If you can prove your abilities, I mean, that's what employers care about in this field. They care about you being able to do the job and solve the problems that need solved. They care a little bit less, or a lot less, about your actual formal background, especially it's very high in demand. So if you have these skills, you're in demand. With what respect do you collaborate with SAE International? I don't think we do anything with SAE International.
We don't have a direct collaboration with them. We, like everyone else in the industry, relies a lot on their level guidelines that you were just talking about, levels of autonomy, but we don't work directly with SAE.
Are we getting LiDARs? I wish we were like Oprah and we could give LiDARs for everybody.
You get a LiDAR,
yeah.
You get a LiDAR, you get a LiDAR.
Unfortunately not. Typical work or effort needed for the course, like we said before, 10 to 20 hours. With David said there's about 17 hours is about average from what we're seeing. Any on-site classes, projects, meetups? Well, we do. We support some meetups. We both, David and I both supported some different meetups. We don't have anything formally, I guess, planned all the time. But if there's a meetup in your area that we're coming to your area, we definitely try to support that. And we are looking at other ideas that we can do with, in-person projects or in-person classes or just different ideas like that. So that's something we're still investigating. But.
Yeah, we like to do kind of in-person events when they make sense and it's a little opportunistic as opposed to kind of regularly scheduled. So for example, next month in September, I'm going to Frankfurt, Germany for the huge auto show in Frankfurt, and we'll be having a big meetup with students in Germany while I'm there. We've done similar things in Denver and in Tokyo and Washington, D.C. Anthony's done it in Boston, I think. And we have a number of events. We've had a number of events here at our Mountain View headquarters in California.
Yeah. I might have lost the question. I think I found where we were. But so can somebody with no knowledge of any sort in programming learn from scratch with no degree? So yes, you can. This isn't the program probably for you. If you've never programmed before, you would hate yourself. You'd hate us for letting you in, and you wouldn't be happy. But we do have programs where you can go and you can learn about how to program. Intro to Programming is a great one. And then we just launched our Data Foundations course, so you could go there and learn about kind of data analysis and different pieces like that. So we are building this pipeline to take you, if you've never programmed before, to introduce you to that, and then bring you up to get you ready for self-driving cars. So, but if you've never programmed before, I probably wouldn't recommend this. You would hate us. I'd see a bunch of nasty comments in here about me and David. So we don't want that.
Could be a frustrating experience.
Yeah. Reposting question about deadlines. A little concerned about keeping the pace week to week or weekly deadlines. So again, there's weekly flexibility in the deadlines, but the project or the end of the term is definitely kind of the end of the term. So you want to have everything done before that. Are all courses online, work at your own pace, or are there on-site face-to-face opportunities? If you're ever in the area, email one of us or post in Slack, tag us in Slack or something, and David and I are usually really good about trying to meet with students and just have lunch with you if you're in the area. As far as learning opportunities, we don't, again, that's stuff we're looking into. We haven't really done too many about that yet. How many peers are in the program? A lot. We've got thousands of people that have joined the program, and if you look at our Slack channel, I mean, it's great because there's a lot of students out there that you can connect with. Hopefully some in your area too. After this course, will you be able to retrofit code on the current car? What is the total bill of material for equipment? So again, this gets into, we're not really teaching you how to build a self-driving car, like the physical aspects of it, but we're teaching you how to code it. So if you had a self-driving car and you're working for a company that has a self-driving car, you would be able to do the algorithmic and the AI and the problem-solving pieces of it. We're not teaching you how to make your car drive by wire. That's much, much harder. And there's a lot of risks sometimes in that too.
It really is kind of a different skill set too. Kind of the work involved in actually getting the car to run involves a lot more hardware, which is great. It's an important excuse me, skill set. But a lot of the hiring that's being done right now for autonomous vehicle engineers, or I should say the vast majority of the hiring, is for people who have software engineering skills. Certainly when I worked at Ford, I worked on vehicles occasionally, but the vast majority of my time was spent writing software because that's what really drives the car.
Are there any grads that have gone on to found their own startups? Well, we haven't had any grads yet, technically, so. But there's a lot of opportunity for that, and hopefully you credit David for teaching you how to program your car and do your own startup. Will there be any course staff TAs that monitor and address questions in the forums? Yeah, we have a lot of TAs, community managers, student service leads that kind of work in the forums to make sure that your question is answered. Can we translate the course to Arabic? We're looking into localization in different areas. I don't know about Arabic yet. Well, I don't know about a lot of them yet. We're still looking into that. We definitely, now that we have all the course content finally out there, now we can go back and look at what we want to translate and what we're able to do.
Michael Lynn says, "Go Cubs, go Cubs."
What kind of industry/ethical standards are followed? I don't know if you mean for our course or for self-driving cars in general. Our course, nothing really. We're just, we're teaching you, and there is some, I think with the electrobit piece, there's a ISO standard that's followed.
Yeah, so in the functional safety module, which is one of the elective modules you can choose in the 8th month of the program, we cover functional safety, which is how to program vehicles and algorithms so that they have acceptable levels of risk, and in particular we follow a standard by the International Standards Organization called ISO 26262. More generally, we're sometimes asked, do we program ethics of self-driving cars? So the famous trolley problem, if you have to either go straight and hit one person or turn right and hit two people, or maybe it's reversed, what do you do? That's not really what we cover in this course, partly because that's more of an ethical than an engineering problem, and partly because self-driving cars, we believe, will just have such a positive impact that sometimes they get lost in the weeds about these kind of hypothetical academic questions about trolley problems. Maybe kind of misses the point that self-driving cars should hopefully save a lot of lives because humans are really bad drivers.
Can I complete the term? Can I complete one term in 1 month as well, or is the course structured in week-month scale? So we give you 3 months, but I have seen somebody complete it as quick as 3 to 4 weeks. And so, yeah, if you get it quicker, then great. You can move on to term 2 faster or term 3 faster. Is there any grace period for the entry fee or a refund that a student should decide to cancel the course? We do have a 7-day grace period, so if you get in and you realize it's definitely not what you were expecting, we do have that option. As Baidu is releasing self-driving car package for free, is there any point to reinvent the wheel? Well, yeah, so I'm guessing you're talking about their Apollo program, which is still very new, and I think Dave and I are both looking into what that is and what, where it could be used. But it is an exciting, I mean, it's awesome. Anybody who's doing something open source, we love that because we just want to see people educated in this area. So we're not exactly reinventing the wheel. We're not trying to teach you a specific way of doing this. We're just teaching you the concepts that go into this. So even if you're using like the Apollo stuff, you'll now know why it's working, because they may abstract that from you, but now you know why it's working, and then you can make it better. To which SAE standards are you referring to? 1939, I think, is a trucking standard for CAN bus, but those are kind of CAN standards. How good should my basics for math stats be for the Nanodegree program? It's good to know, like, through calculus or have been through calculus and understand, like David was saying, like linear algebra, how to multiply matrices and everything. Let's see if I can get to one more program. How to learn it faster.
Put more effort in.
Put more effort, yeah, spend more hours per week. That's the best way I can say to learn it faster. There's a whole bunch of questions that, unfortunately, we're not going to have time to get to. So it sounds like we're going to have to do this again, David, because they definitely feel it's more questions.
Thank you so much for sending in so many great questions. We hope all of you who are eligible enroll in the Nanodegree. We really want to see you in class. And the folks who are already enrolled and asking questions, thanks so much for the great questions. You can send them also to us on the student Slack community. I think I'm just David. Udacity, in the Udacity employee Slack, I'm David.Silver, but in the student Slack, I'm just David. And Anthony, you are A. Navarro?
A. Navarro.
Okay.
Yeah. So you can find us on Slack. And again, if you're ever in the area, feel free to stop by. We can have lunch, have a beer.
Yeah, we love to see students at the office. Send us a note.
Yeah. Thank you for joining us.
Thanks so much.
Bye.
Bye.